Okay. So, introduction to polynomials. And today we're just classifying whether something is a polynomial or not. And I'm going to skip straight to this slide. I wouldn't worry. I'll tell you, if you're taking notes, what you should probably be worried about writing down. This stuff, I wouldn't really worry too much about it because it's kind of self-explanatory. If you want to write down maybe the examples at the bottom, that would be good. So a polynomial is a monomial in the form of ax to the n, where x is a variable, a is a constant, and n is a non-negative integer. A polynomial can also be the sum of monomials, each called a term of the polynomial. Some polynomials have special names. A binomial is the sum of two monomials. A trinomial is the sum of three monomials, and so on. And the reason I said that this is sort of intuitive, so a polynomial is really just any amount of stuff added together, variables and constants together, right? So all those three things at the bottom are considered a polynomial. And then some of them just have special names, right? Monomials when there's one term, binomials when there's two terms, trinomials when there's three terms, right? Fairly straightforward. And the rules are basically, what it says here. So the big thing is n is a non-negative integer. So that means a positive integer. I don't know why they didn't just say positive integer, but they decided to say non-negative. So n0 is okay as well. So you can't have negative exponents, and you can't have. So here's kind of the rules for what's not a polynomial, which you might want to jot this down somewhere. Anything that's not going to have a or that's not going to be a polynomial is going to have. There should be no negative exponents, right? Because it says non-negative integer. So if you have a negative exponent, not a polynomial. Negative exponents also means dividing by a variable, right? So if you have a negative exponent, that's the same as dividing it, right? If you have b to the negative 3, that means 1 over b to the third. So these are really the same thing, right? If you have a negative exponent, you're dividing by a variable. You can't do it. And then really the only other one is you should have no roots, right? Because if you have roots, that also implies that you don't have an integer as a power. So like, right, if you have the square root of x, then that implies that's x to the 1/2. Right? You could divide by constants and numbers, and you could have square roots of numbers, but you can't do that when with the variable, right? So if the variable has a negative exponent, or you're dividing by a variable, or you have the some root of a variable, you can't do it. We'll leave this up just for another second in case anyone is jotting it down. I'm waiting. I'm waiting. Oh my god. Huge car. Nice. Anyways, the degree of a polynomial is the sum of all the exponents of its variables. A non-zero constant has degree 0, and 0 has no degree. So little difference there. So that means if we had a monomial like 5x to the third y squared, the degree is going to be 3 plus 2, or 5. Right? The sum of the exponents. So 3 plus 2, degree is 5. The degree of a polynomial is the greatest degree of any term in the polynomial. You can find the degree of the polynomial by finding the degree of each term. So like if I had 5x to the fifth minus 4x squared plus 1 or something, then the degree would also be 5 because it's just the highest number wins, right? And if we had, I don't know, if our polynomial was just 25, then the degree would be 0 because it's kind of like we have an x to the 0 here, right? Something to the 0 is 1. 25 times 1 is just itself. So that's where that comes from. And that's the reason why 0 doesn't have a degree, because it's not like we have x to the 0 here, because that would be 1. 0 times 1 is still 0, right? So that's why there's no degree for those. Basically, if it's monomial, just add them up, and if it's a polynomial, it's just the highest one. So from here on out, we're just determining if things are polynomials, which this is what will be useful for that, these three things. So determine if the following expression is a polynomial or not. If it is a polynomial, state the type and degree. So this is a polynomial. It is. So I'll just write yes. That is a polynomial, right? It doesn't break any of our rules. It doesn't have a negative exponent everywhere. It doesn't have any variables being divided or in a root or anything. So that is a polynomial. State the type and degree. That is a monomial because it's a single term. And the degree is 0. Right? Because it's like we have x to the 0 here. So 0 degree. This one, determine if the following expression is polynomial or not. Again, it's not breaking any rules. We don't have negative exponents, not dividing, no roots. So yes, it is a polynomial. The type is still a monomial, right? Because there's only one term, even though there's a bunch of things here, it's one term. If it's all multiplied together, it's considered one term. It's not considered two terms until you have a plus or a minus some stuff. So it's still a monomial. And then the degree is going to be the exponents added, remember. So we have 7 plus, and then there's an invisible 1 here. So the degree is 8. Oops. Okay. This one, same thing. We don't have any variables with a negative exponent or anything. We have a -6, but that doesn't matter, right? But now we just have two terms. So that's going to be a binomial. And the degree is still, the highest is 7 plus 1, which is 8. Not too bad. For this one, this is not going to be a polynomial because we have this x to the -2 right here. So negative exponents on the variables, can't do them because that would put an x squared in the bottom. So this is just not a polynomial because of this -2. Not just because it's the -2, but because it's a variable. It's the -2. Right. If it was just a number to the -2, like if it was 5 to the -2, then that would just mean 1 over 25, right? 1 over 5 squared. That's just a constant. That's fine. This one we are dividing by 7, but that's just a constant, right? That's almost just like saying 1/7 times a to the fourth, right? We can have constants. That's totally fine. So this is a polynomial because we're not dividing by a variable. We're just dividing by a constant. And this is a trinomial because there's 1, 2, 3 terms. So trinomial. And the degree is the highest one. So here's 4, 7, and 13. The highest one is 13. Highest one always wins. A few more to get through. I know I'm going a little fast, but the video will be up if you just need to like leave some space and copy some of them down. This one is not a polynomial because we are dividing by b. That's the same thing, that's like if we had a to the fourth, b to the negative first, right? Same thing. And we know that negative exponents aren't allowed or division by a variable, essentially the same thing. So not a polynomial for this reason, this guy right here. Okay, and this one similarly, nope, because this square root of y, this is the problem, right? That's like y to the 1/2. 1/2 is not an integer, so that's why this is not a polynomial. Couple more. This one is a polynomial, right? We have a square root, but this is just a number. This is totally fine. This is a constant. The square root of 3, you could plug that in your calculator and you just spit out some constant. That's totally fine, right? And we have 2 terms, so it is a binomial. And the degree is 1, right? Because we have an x to the first, that's the highest degree. This would be 0 degree, so the highest is 1. Right? Square root of 3 feels wrong, right? When we looked at this square root and we said nope, but because it's just a constant under the square root, that's totally fine. And then the last one here, and really to classify it as a polynomial or not, just be really careful and just look at all of your variables because that's really all that matters. This negative doesn't matter, right? That has nothing to do with this variable. So x to the fourth is good, y to the third is good. The square root of 3 is good because there's no variables underneath it. And x to the fifth is good, even though there's a minus here that's not in the exponent. So this is a polynomial. More specifically, I know there's a lot jumbled here, but this is one term and this is one term, so it's a binomial. Right? If it's multiplication altogether, it's considered one term. And then lastly, the degree. You might look at this and you might want to say 5 is the highest degree, but remember we have to add these. So we get 4 plus 3, which is 7. So that's actually the degree because 7 is higher than 5. You take the highest one.